Hi everyone, I hope you've had a beautiful day. This is You're Not Stupid. Why? Because you are a person full of potential, and if you don't know about something, then you don't know about it. It doesn't make you stupid. Okay, great. I'm Nadia Halliday, and this is You're Not Stupid. And I thought we would talk about types of numbers today. I was thinking about doing a Venn diagram. We'll do Venn diagrams another time, but I thought I'd do this as a table. So I'm going to do it like this, like a crosshair type of thing, like this. And I'm going to put the examples in here. Okay, so we're going to be talking about, I've been really thinking about this evening. Integers, oh, excuse me, sorry. Integers. That was the pie talking to me. It was a rather nice pie I had today. Right, so talking about integers. We are talking about non-integers. We're also going to talk about these are like different numbers that get grouped together, and we're talking about all numbers here. Yeah. So we're also talking about rational numbers and irrational numbers. Irrational. And I'm going to go and put in some examples in these for squares so you see what I'm talking about. So integers are always whole numbers, including the number naught. So you could say something like 365, or you can also say minus 20 is an integer. So anything that's a whole number and there's nothing after the decimal point. So let's go and show you that. So if it was 1.01, then that shows a figure or digit that's after your decimal point. So that means that is not an integer. Doesn't equal an integer. We'll see what that equals in a minute. what it adds up to. See what I did there? Haha. So we've talked about a few integers. The other integer you need to think about as well when it comes to whole numbers is the number 0. That's also included. So integers are whole numbers which are either positive or negative and include the number 0. Okay, so non-integers, this is where it gets interesting. Yum, yum, yum. Non-integers are fractions. Fractions can go in here. And also some other things can go in here. So fractions, they're rational numbers. Rational numbers means that they can be equated in quite a simple way, rational numbers. So rational numbers also, like I said, also include integers. So they can be written simply. So can, would you believe it, fractions. So fractions are things like 1/2, which is the same as saying a half. 1/3, which is a third. There can also be things like 7/4. Another fraction can be, but I'm going to put it over here and I'll show you for why. 5 over 1. But 5 over 1 is the same as saying 5, which is a whole integer, right? Yes. Okay. So that is, we talked about integers, we talked about fractions, and we talk also I need to share with you this type of fraction. Next thing now. We do 1 over 3. Okay. So I'm going to go back to 1 over 3. It's also the equivalent of saying 0.33333 reoccurring. Reoccurring. So that means that can actually be written up as a fraction, as you saw before. 1 over 3 is the same as 0.3333333. Okay? And that is counted as a rational number. Okay? The other number that we need to look at is irrational numbers. What do they look like, Nadia? Well, let me share with you the definition. They can't be written as fractions, rational numbers. They are never-ending, non-repeating decimals, and usually, not saying every time, but usually, in fact, yeah, well, I'm going to give you an example of something that is irrational but is not this. Usually there's a square root or something. So square root of 2, it doesn't repeat, is it's 1.412, and it just continues. I cannot remember the rest, sorry. The square root of let's see now, I did write this down so I'll make sure I remembered it. Yeah, square root of 3, that's an irrational number. The square root of 7. So if you do a square root of something, it's always going to be a number that will be, of course, smaller than what is being square rooted, but then the number just continues and continues and continues, and you can never get to the end of it. So in the end, it's easier just to go and write it up as the square root of a whole number. But effectively, it's an irrational number. Also, let me show you this. Square root of 4. Is that irrational or rational? You can stop this video to think about it and then carry on. 3, 2, 1, stop. 1, 2, 3, and we're back in the room. So, square root of 4 is 2. So that means that this would turn out to be a rational number, which is also an integer. Yeah? Great. Okay. The other one I wanted to share with you that is also an irrational number is the number pi. Go look it up. Go and look on Google or Safari or Explorer or Chrome and find out how many numbers is equated to pi. It's amazing. This number is the answer to everything to do with circles, spheres, cones, even cones. Oh my gosh, it's amazing number that you can use for so many things. I can't wait till I share with you about circle theorem, but that's when you have to get into your grade A maths. Sorry, wait a minute. Thinking about I've got to remember to go and regrade my brain, because it's not grade A anymore, grade A plus, is it? It is grade 8 or grade 9. So yes, those are the sort of questions that we can build up on and be excited about and enjoy and explore in maths. So let me go and finish off this pi. So it's 3.1415. I think it's 9, but I'm not going to say anymore. But usually I usually just do it to 3 decimal places. So it'll be 3.142. That's usually adequate for using in any of your calculations when it comes to calculating the volume of a sphere or the area of a circle, for instance. So I think we can stop it there. I am going to talk about BODMAS tomorrow, but I just wanted to share with you all that. Oh dear, I nearly forgot this other bit. You cannot get integers that are irrational. See what I did there? I know, right? I was like, it's like, how come that's blank? You cannot ever get integers that are irrational. Irrational numbers are things that will be, they would have digits after the decimal point, always, always, always. And you never get to the end of that number. It's an infinite number. Wow, that is kind of cool. Infinity, is that an irrational number? No, that's not an irrational number. That is always a whole number as far as I'm concerned. That's an interesting question actually. Is infinity a rational or irrational number? I've never thought of that before. I think it's rational. I'm sure it is. But, something to think about and maybe explore by yourselves. Anyway, so that is my video for today. I am realising you might have missed a little bit there. So got rational, irrational on the table. And at the top, you've got integers and non-integers. And remember, you cannot get integers that are irrational. That is not a thing. So the types of numbers you can get in maths. I shall see you all tomorrow. We'll talk about BODMAS tomorrow. Excited! That is going to be so much fun. I'm going to see if I can find some equations to go and play with that we can do as a few examples for tomorrow. See you all tomorrow. Thanks a lot. Bye-bye. Bye.